Understanding the weather, long questions with answers in 80 to 100 words each. How do different weather elements interact to determine the weather in a region? Weather is determined by a combination of several elements including temperature, humidity, wind, atmospheric pressure and precipitation. For example, high humidity can make the air feel warmer, while low pressure systems are often associated with cloudy weather and storms. Wind carries air masses with different temperatures and moisture levels, influencing weather patterns across regions. The interplay between these elements, such as how warm air rises and cools, can result in precipitation, thunderstorms, or dry conditions. Weather changes occur due to the continuous interaction of these variables in the atmosphere. What is the importance of understanding atmospheric pressure in weather forecasting? Atmospheric pressure is crucial in weather forecasting because it helps meteorologists predict weather changes. High pressure areas generally lead to clear, calm weather, while low pressure areas are often associated with storms and rainy weather. When air pressure rises, it indicates fair weather, whereas a drop in pressure signals that a storm or bad weather may be approaching. By studying pressure changes, weather stations and forecasters can predict the likelihood of weather events such as cyclones, thunderstorms, or heavy rainfall, which is vital for public safety and planning. Explain how a rain gauge works and its importance in weather monitoring. A rain gauge is a simple instrument that measures the amount of precipitation that falls in a specific area over a period of time. It consists of a funnel that directs rain into a container, which is marked with measurements. The amount of water collected is then measured in millimeters or inches. Rain gauges are important because they provide accurate data on rainfall, helping meteorologists monitor and predict weather conditions, track droughts or floods, and understand seasonal precipitation patterns. This data is vital for agriculture, water resource management, and flood forecasting. Describe how weather instruments like anemometer and barometer help in weather forecasting. An anemometer measures wind speed, which helps meteorologists determine the strength of wind patterns and predict storms, hurricanes, and calm weather conditions. By knowing the wind speed, forecasters can predict the movement of weather systems. A barometer measures atmospheric pressure, providing insight into upcoming weather conditions. A falling barometer typically indicates approaching bad weather, while rising pressure is associated with clear skies. Together, these instruments help forecasters track weather patterns, identify changes in air pressure, and predict wind-related events like cyclones and strong gusts. How does the use of satellites enhance our understanding of weather patterns? Weather satellites are essential tools for observing and tracking large-scale weather patterns across the globe. They provide real-time data on cloud formations, temperature, wind speed, and atmospheric moisture. Satellites can monitor the development of storms, hurricanes, and other severe weather events from the space, which is crucial for early warning systems. By providing an bird's eye view of Earth's weather, satellites allow meteorologists to make more accurate predictions about weather changes. They also help in studying long term climate trends, making them invaluable for both short term weather forecasting and long term climate research. How do clouds form and what role do they play in different conditions? Clouds form when warm, moist air rises and cools, causing water vapor to condense into tiny droplets or ice crystals. These droplets or crystals group together to form clouds. The type of cloud formed depends on the temperature, altitude, and moisture levels. Clouds play a crucial role in weather because they are associated with various weather phenomena such as precipitation, thunderstorms, and fog. For example, cumulonimbus clouds are responsible for thunderstorms. Okay, cumulonimbus clouds are responsible for thunderstorms, while stratus clouds bring overcast skies. So clouds also help regulate Earth's temperature by reflecting sunlight or trapping heat. What factors contribute to the formation of cyclones and how do they impact weather? Cyclones form over warm ocean waters, where the temperature of the sea surface is higher than the surrounding air. The warm air rises, creating a low pressure area, and as the air moves in to replace the rising air, it begins to rotate, forming a cyclonic system. The cyclones are characterized by strong winds, heavy rain, and storm surges. They can cause widespread damage, flooding, and loss of life. The intensity of a cyclone depends on the temperature of the ocean, the moisture in the atmosphere, and the atmospheric pressure. Their impact includes destruction, power outage, and displacement of communities. How does the movement of air masses influence the weather in different regions? Air masses are large bodies of air that have uniform temperature and humidity characteristics. When air masses move, they bring changes in weather to different regions. For instance, a warm, moist air mass from the tropics may bring warm, rainy weather, while a cold, dry air mass from polar regions can cause cool, dry conditions. The boundary where two air masses meet is known as a front, and weather phenomena like storms, rain, or snow often occur along these fronts. The movement and interaction of air masses are critical in determining regional weather patterns. What is the significance of the dew point in weather forecasting? The dew point is the temperature at which air becomes saturated with moisture and water vapor begins to condense into liquid water. The dew point is important because it indicates the moisture level in the air. A high dew point suggests a high humidity, making the air feel warmer and sticky, while a low dew point indicates dry air. The dew point helps meteorologists predict the likelihood of precipitation, fog, or frost. If the dew point is close to the air temperature, condensation will occur, leading to rain or fog. This is crucial for accurate weather forecasting. Discuss the role of weather stations in gathering data for weather predictions. Weather stations are equipped with various instruments to measure different weather elements, including temperature, humidity, wind speed, atmospheric pressure, and precipitation. The data collected from these stations are vital for weather forecasting. Weather stations may be located in airports, research centers, or remote areas and provide real-time data that meteorologists use to track weather systems, analyze trends, and predict future weather patterns. Automated weather stations, in particular, provide continuous, up-to-date information, helping meteorologists issue timely weather alerts, warnings, and forecasts for public safety and preparedness. Thank you very much.